Hello everyone, welcome back. In this video, we are going to learn another important concept in Java multithreading with a clear explanation and practical examples. Subscribe to the channel to keep learning and growing your Java skills. Now let's get started. So, creating threads in Java. You can create a thread in Java with just a few lines of code. That's very simple. But there's one small mistake that can completely change how your program executes. Okay, just look at these two lines. Thread dot start and thread dot run. So they look like they should do almost the same thing, but they behave very differently. Okay, so one can start a new thread of execution, while the other may simply execute like a normal method call. So in this video, we will learn the two fundamental ways to create threads in Java. One is by extending the thread class and another is by implementing the Runnable interface. Okay, so these are the two ways to create threads. And the most importantly, we will see exactly what happens when we call start versus run. Okay, so let's begin by creating our first thread. So Java provides two fundamental approaches that we can use to define work for a thread. Okay, work for a thread means, suppose we have different threads. Okay, we have different threads, so each threads will be performing some work. Okay, so let's say T1 thread will do W1 work, T2 thread will do W2 work, and likewise T3 will do W3 work. So we need to define work, what this thread will do for each thread. Okay, so first let's see how to create threads. So the first approach is to extend the thread class. So this is first approach. And the second approach is to implement Runnable interface and provide that Runnable to a thread. Okay, so we will implement Runnable interface and provide Runnable to a thread. Okay, now let's understand both approaches with practical examples, starting with the thread class. Okay, so let's go to IntelliJ and I will show you how to create a thread using extending thread class. Okay, so I will create one class called my thread. Okay, my thread. So this is the class which will extends thread. Okay, so there are two approaches for creating thread. One is the extending thread class and another is implementing Runnable interface. So currently we are looking by extending thread class. This is thread class, built-in class which is provided by Java. Okay, so here we create a class called my thread and extend thread. Then we override. Okay, then we override which method? Run method. So public void run, and inside run method what we will do? So the run method comes. Okay, okay, so here inside run method I will just write thread is running. Okay, so the run method, what it will do? So the run method contains the task that we want our thread to perform. As I explained, each thread will work something. In the example, so T1 thread will be performing some work like W1. So for this thread, my thread, this work will be done. Whatever work we are writing inside run method. Okay. So in this example, we are simply printing thread is running. But defining the run method alone does not start a new thread. Okay. So for that, we first need to create an object of our myThread class. Okay. So let's go to main method and create an object of our thread class. So how can we create myThread? So we are creating thread now. Okay. New myThread. Okay. So what we have done so far, I have created one thread using extends thread class. So this is one of the method to create thread. And inside this thread, I have provided what work this thread will do by providing inside run method, overriding run method. And now I am creating an object of this thread and I'm writing. Okay. So inside the main method, we created an object of myThread. See, new myThread. Now comes the important point. To start the thread, we call the which method? Start method. Okay, so when we call start, the JVM starts a new thread of execution. Okay, so in this line, new thread of execution will start. And eventually invokes the run method. So whenever we call start method, it will create a new thread of execution and it will invoke the or call the this run method. Okay. So think like main thread. See, main method will execute means we have one main thread. Okay. And from that main thread, inside that main thread, we are creating another thread. Okay. So we created another thread. But what this new thread will do? So we have defined in the run method what it will do. Okay. So when we call start method, okay, it will create a new thread of execution. That means it will create a thread, myThread, and start of execution means it will call the run method, what this thread will do. So that will be, this method call will be happening inside start method. Okay. So we call start. Then let's verify then these are actually different threads or not. Okay. So what I will do inside run method, instead of printing thread is running. Okay, let's run and verify what is happening. So see, in the output it is showing thread is running. That means when we are calling start method, it is creating new thread of execution, and in that thread it is calling run method, that what work this thread will do. So this is defined here. So this is getting called and it is printing thread is running. Now let's say instead of printing thread is running, I will simply mention like which thread is running. Okay, so for that we have a built-in method called thread.currentThread.getName. So it will give us the name of this particular thread in which this run method is getting called. Okay. So now I will rerun the same program. We will see which thread is running. See, thread 0. Okay. So we can verify which thread is executing our code by using this method, thread.currentThread.getName. Okay. So we will print it again inside the run method. So when we execute the program using start, notice the output. The main method executes on the main thread. As we already know, the main method belongs to main thread. Okay. And while the run method executes on a different thread, this confirms that calling start created a separate path of execution. Okay. So think like we have one main thread and Inside this main thread, we created another thread that is performing some other task. And when we hit the start method, when we call this start method, that thread is getting created and it is getting called. Run method is getting called. Now let's look at the second approach to define task for a thread. Okay, what was the second approach? Second approach was implement runnable through runnable interface. So I will again create a new class. Okay, this time I will write my task. Okay, implements runnable. So we already know, right? We have two methods. We have two ways to create a thread. One is extend thread and another is implements runnable. So first method we already covered. Now we are moving to second approach. Okay. So we are implementing runnable. Runnable is an interface which has run method. So we need to override run method. Okay. So I am writing run method. And in this I am just printing task is running. Okay. So what is the second approach? Second approach is to implement a runnable interface. So here, instead of extending thread, our myTask class implements runnable. So runnable is a functional interface that represents a task that can be executed. Okay, it contains the run method. So we provide the task logic, what this task will do as part of run method by overriding it. So there is one important difference here. Okay, my task itself is not a thread. Okay, it only represents the task that we want to execute. Okay, so think like, so as I explained, each thread will perform some work, some task. So that work or task we are defining here, what that work and task will be. But this work or task we have not assigned to any thread yet. Okay, so how do we actually run this task on a new thread? Okay, so for that we will, okay, I will comment this out. So for that I will create an object of my task class. Okay, so this is just a task, what the thread will do, but we have not assigned to any thread. Okay, so for that we should have the thread. So let us create a thread. New thread. Okay, so inside this thread we will provide task. Okay, so we already know that one thread, there will be one thread, and that one thread will be performing some task. So for that we have first defined the task, and after this thread we created thread object. In this thread object we are passing what task this thread will do. And once this thread knows what task to perform, we can simply write thread.start. So thread.start, what it will do, it will create a new thread of execution and it will perform the task by calling the run method. Okay, so what we have done so far, first we created an object of my task, then we created a thread object and pass our runnable task to its constructor, and finally we call start on the thread object. So the new thread then executes the run method defined by our runnable. Okay, this approach gives us a useful separation. Runnable represents what? Runnable represents what task that should be performed, while thread represents what? Thread represents the thread that executes that task or work. So this separation is one reason why implementing runnable is generally more flexible than extending thread. Okay. So let us run the program and check the output. See, task is running. That means when we are calling start method, the thread process is starting, it is creating new thread, and as part of that thread, it is performing task. What task it is performing? Inside run method, what we have provided, task is running. So that is being performed. Okay. Now, we have seen two approaches to create a thread with example. Now, so which approach should we use? That is the question. So when we extend a thread, our class become tightly connected to the thread class. Okay. So we have seen two ways. One is extending thread and implementing Runnable. So for extending thread, we extend the thread class. And for implementing Runnable, we implement Runnable interface. Okay. So when we extend thread, our class becomes tightly connected to the thread class. Okay. And as we already know, Java does not support multiple inheritance of classes. So that class cannot extend another class. Okay, so let's say we have defined any class, my thread, and we are extending from thread class. So this class already extending from one class. So we cannot extend multiple classes since Java does not support multiple inheritance through classes. Okay, so this is one drawback here, extending thread. But with Runnable, our task is separated from the thread itself. We have seen with the example, task is separated from the thread. We are creating tasks separately and thread separately, and later we are assigning this task to this thread. Okay, so we can extend some another class for this thread class since we are implementing the Runnable interface. Okay, so this makes the design more flexible in this case. So in most cases, separating the task from a thread by using Runnable is preferred. Okay, so here can still extend the another class because since it is not extending from any other thread class, we can use or extend another class. But here we have already extended one class, we cannot extend another class due to multiple inheritance through classes. Okay, and we have seen it is more flexible. Why? Because we are creating tasks separately and thread separately, and then we are assigning this task to the thread. So this is more flexible as compared to extending thread. So in modern Java application, you will also commonly use higher level concurrency APIs such as executor service. Rather than manually creating threads for every task, we will use executor service. We will see in the later upcoming videos. Okay, so now we are ready to answer the question from the beginning of the video. What exactly is the difference between the start and run? Okay, so this is one of the most important concepts to understand when working with Java threads. Okay, if we call thread.start, okay, so Java starts a new thread of execution. So the JVM then invokes the run method on that new thread. It calls the run method on that new thread. Okay, but what happens if we directly call the run method? So in that case, no new thread will start. Run method behaves like a normal method call and executes on the current thread. Okay, so think it like, so we have one main thread, and inside main thread we are calling start method. So what it will do, it will create a new thread, let's say T1, and in this thread it will perform some work. How? By calling run method. So if you are calling start method, it is creating thread and it is calling this run method on the new thread. So in run method means work will be there in the run method, what work we need to do, what task we are performing. So those tasks or work will be performed as part of this new thread. Whereas let's say we have main thread and we are calling run method. So run method will not create any new thread. Instead, what it will do, it will call the run method inside as part of this main thread only. So this is the difference between the start method and run method. Okay. So start and run are definitely not the same. Calling run means executes the method. Calling start means starts a new thread which then executes run method. Okay, so let's prove this by looking at the thread names. Okay, so we have already created threads, right? In the main method, if I go to main method, we have already created a thread. See here. Okay, I will comment this. I will write once again. Okay, so we have my thread class. Okay, so we will use this. We have my thread class extending thread and we have run method. Now what I will do, I will create an object of my thread. Let's say t1 equals to new my thread. So before I run this code, try to predict the output. Okay, so first I am calling the run directly. Which thread do you think will execute this method? So let's run it. So notice the thread name, it is main thread. Why it is main thread? Because we never started a new thread. We simply called run like a normal method. Now let's change run to start. Watch the thread name again. This time, see we got the different thread. Its name is thread-0. So that is the key difference. Calling run directly does not start a new thread. Calling start method requests a new thread of execution and that new thread executes the run method. Okay. So now we understood the difference between the start method and the run method. But there is one more important rule you should know. A thread object can only be started once. Okay, so in line number 20 we are creating a thread object, but this thread object can be started only once. Okay, if we call start on the same method, okay, start on the same, okay, same thread object again, let's say t1 dot start again after it has already been started. So Java will throw an illegal thread state exception. Okay, it will throw illegal thread state exception. So we will get this exception if we try to again run the start method. Okay, if you need another thread, you must create another thread. So this is like common mistake when developers first start working with multi-threading. So remember, one thread object can be started only once. Okay, so we will see. So here is the simplest way to remember everything we learned. The run method defines the work that should be performed. Okay, so here is the run method. It will define what task needs to be done. A thread represents a thread of execution. And calling start begins the life cycle of a new thread. Okay, calling start means here start method. Okay, so when we call start method, it begins the life cycle of a new thread. Okay, which internally executes the run method. So if someone asks you the difference between the start and run, remember this: calling run directly is just a normal method call. Just a normal method call. But calling start method starts a new thread of execution that will call the run method. So that single distinction is fundamental to understanding Java multithreading. Okay. So now we know how to create and start threads in Java. But once a thread is created, what actually happened to it? Is it immediately running? What happens when it sleeps, waits, or finishes execution? A thread goes through different states during its lifetime, and understanding those states is essential when debugging multi-threaded applications. So in the next video, we will understand the complete thread lifecycle in Java and see how a thread moves from one state to another. So that's all for this video. I hope you now have a clear understanding of creating a threads in Java. Thanks for watching, and I will see you in the next video.